Hi all, this is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Course name is Unconventional Machining Process. Today's topic is Applications and Advantages of Photochemical Milling. Okay, right. At the end of this session, student will be able to understand applications and advantages of photochemical milling. Okay. Now let us discuss non-traditional machining process before we discuss photochemical milling and its advantages. Okay. So informal non-traditional machining process or processes are classified basically into three main categories: mechanical, thermal, chemical and electrochemical. Okay. Under mechanical, ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. Okay. Right. Under thermal, electro discharge machining, electron beam machining, laser beam machining, ion beam machining, plasma beam machining. In chemical and electrochemical, chemical milling, plasma chemical milling, electrochemical milling. Okay. So now we are discussing plasma chemical milling. Photochemical milling, PCM. Right. Photochemical milling is a variation of chemical milling where the chemically resistant mask is applied to the workpiece by photographic techniques. Okay. So here we are applying photographic techniques. Okay, in photochemical milling. The two processes are quite similar because they both use chemicals to remove metal by the CD action, and some of the steps required in both cases are similar. Okay, so in chemical milling and photochemical milling, some of the steps are similar. Okay, right. Chemical milling is usually used on solid parts or three-dimensional parts, okay, which are formed by another manufacturing process such as forging and casting of irregular shape. Okay, so already we know what is forging and what is casting. Okay, so usually we make some parts with some manufacturing process with forging and casting, and for final operations as per our requirement we need to deploy these chemical processes. Okay, so upon some manufacturing or manufactured parts we have to machine. Okay, right. As with photochemical machining, areas not to be machined are masked from the CD action of the chemical solution. Okay, photochemical machining therefore creates new parts from thin materials rather than simply smoothing or altering parts formed by other manufacturing methods. Now let us see the applications. Okay, let us go through these applications. Aluminium, copper, zinc, steel, lead, nickel, titanium, molybdenum, zirconium, glass, ceramics, and some plastics are photochemically machined. Okay, Now let us look at these materials: aluminum, copper, zinc. So usually we use steel in almost all applications. Okay, lead, nickel. Okay, we don't use titanium for general applications, but for industrial applications and where some aesthetics are very much important. Um, when high strength to weight ratio of the material is required, we have to go with titanium. Okay, and molybdenum, zirconium, glass, ceramics, and some plastics. Okay, right. So these are the various materials applications in photochemical process. Right. Very high tempered or brittle materials are excellent candidates for photochemical machining because traditional machining causes breakage or stress concentration points. Okay, so here one is breakage, the other may be induced stresses, that may be stress concentration. Okay, the process also works well on spongy materials which are difficult to punch. Okay, so here very high tempered or brittle materials are excellent candidates for photochemical machining because traditional machining causes breakage or stress concentration points. See, for ductile materials, we can use conventional machining process for the material removal. Okay, but for very high tempered and brittle materials, if we try to remove very minute particles from those materials, okay, and at the same time the material thickness is very low, what will happen? One is breakage, the other one may be the induced stresses may develop in that material and subsequently it will fail. Okay, right. Plasma chemical, sorry, photochemical milling of decorative and artistic designs. Now look at this artistic designs here. Okay, this one, PCM lends itself for decorative and graphics industries where signs and labels are produced as shown in figure 2. Okay, see here, this is aeronautical applications. Okay, so this is somewhat artistic. Okay, these are having some crafting. Okay, and this shows some culture and somewhat artistic designs. Okay, so these are the various decorative and artistic designs by photochemical materials undergoing photochemical milling must be thin with a thickness between 0.013 and 1.5 millimeters. Already we have discussed that it is very difficult to remove the material from the thin metal sheets, okay, by conventional methods, but with photochemical milling it can be possible. Okay, so that's why for the artistic designs with minute profiles and intricate shapes on thin sheets can be make with this by using this photochemical milling. Next, second one, the materials must also be flat so that they can later be bent to shape and assembled into other components. Okay, usually while machining, the components should be very regular, that means flat. Okay, so later the chemical process, what is that, photochemical milling, we can bend it into required shape and we can assemble the various parts to make the components. In this regard, etching four lines to flat components for fabrication of boxes and enclosures is a typical PCM application. Okay, so this is the reason behind that, flat components. Okay, right. Products made by photochemical machining are generally found in the following industries are, um, what is that called, companies. Okay, electronic, automotive, aerospace, telecommunication, computer, and medical and other industries. Okay, so photochemical machining or photochemical milling is very popular, particularly in aeronautical applications, aerospace applications. Okay, but in general, we use in electronic industry, automotive industry, aerospace industry, telecommunication, computers. Usually, some hardware components should be very typical profiles. So where the other conventional methods cannot be make this kind of profiles. So that's why we are going with photochemical machining, and particularly in medical field. Okay, so most of the surgical instruments and in medical field, some organs will have to be developed. So for those things, we have to make some profiles or templates or some dyes. So where we have to use photochemical machining. Okay, right. Here you look at here typical components in figure 3, typical PCM blanks. Okay, so here what we are doing, we are making some blanks here. Okay, so already some manufactured part is there, but we need to make some blanks. Nothing but we have to remove a certain portion. Okay, so for that also we have to use this photochemical machining. Okay, so here components include filters and screens, gaskets, lead frames, contacts, connectors, probes, and flat springs. Okay, so here you look at here, some gaskets are there. Okay, and lead frames. Okay, and contacts, connectors, probes. Okay, so all these things should be done by photochemical machining process. Okay, so the source is that, here, chemat.com. Okay, right. Again, figure 4 shows different photochemically machined patterns. So not only the particular profiles, but also in order to make certain patterns, that means some repeated things can be frame on a surface of the workpiece or some material. We have to go with photochemical machining. See here some regular process or regular pattern that we can observe here. Okay, so we need not go for the each and everything with a process. Directly we can make a template so that automatically the chemical process will develop the required profile. Okay, so these are nothing but the patterns. Okay, see here we can have the similar patterns for the entire surface of the workpiece. So here also same. Here also same. Okay, these are nothing but the patterns. Okay, right. Samples of PCM machine patterns. So when we have the similar kind of patterns or similar kind of features, that is nothing but pattern in general, we have to use photochemical machining. And after developing the individual parts, we can combine to make components, and finally we can assemble to get the final desired shape on the some decorative purpose or some aesthetic purposes or some industrial applications. Okay, we need to make some patterns for the industrial purpose too, not only for aesthetics. Right. Now let us discuss the advantages of photochemical machining. Right. In addition to the general advantages of chemical milling and photochemical machining, ensure the following merits. Okay, a relatively low cost per unit. Okay, here the first one is the cost component. Okay, relatively low cost per unit, especially at low production volumes of complex designs, because the tooling is very inexpensive compared to shearing punches and dies. Okay, so whatever it may be the production volume, okay, based on the complexity of the designs, okay, here photochemical milling will lead to low cost per unit. Okay, right. And lead times are often small compared to the compared to that required by process that require hard tooling. Okay, so here lead times are also very comfortable. Okay, one is cost and the other one is time. If we save time, then obviously it can be reflecting to the cost of the product or machining process. Some design changes require simple alterations to the photochemical machining process, such as the time of etch or the type of etchant, which changes features such as the hole size and depth of etch. Okay, so here based on the design, we can simplify something like the hole size and depth of the edge. Okay, so let me reiterate that one. Some design changes require simple alterations to the photochemical machining process, such as the time of etch or the type of etchant. Okay, either we modify the time of etch or the type of etch. Okay, sometimes we can alter both. Okay, which change the features such as the hole size and depth of edge. Okay, so usually depth of edge and the hole size. Okay, these two are very much important. Okay, so based on that design change, we can modify the time of edge and the type of edge. Okay, so final parts are produced in the same manner as the prototypes. Okay, so once we apply these designs and design features to the prototype, automatically in proportionate to that prototype designs, the final parts will be the same line. Right, the process is bar free. Already we have discussed that in conventional machining process, usually there is a scope of formation of burrs over the surface of the workpiece, but here because of the chemical action, the complete removal of the debris will be possible, and at the same time no burrs, the material, the particles will be removed completely. Okay, so that we will get the fine quality and fine finish. Okay, next, it does not change the hardness, grain structure or ductility of metals. While metal shearing imparts stresses in the components and laser machining creates a heat affected zone. Okay, so usually ductility, the grain structure, and hardness. Okay, heat affected zone. All these are very important parameters of the materials or the final shape and size and its application and its performance. Okay, so it should not be altered even after the excuse me the components when subject to laser machining. Okay, so here it does not change the hardness, grain structure, or ductility of metals. So usually in conventional machining process, because of the induced stresses, the material will subject to some change in ductility or grain structure. Okay, even hardness also may change. But here with this photochemical milling, these things will not alter. Okay, in laser machining also, the heat affected zone may be one of the important parameter. Okay, but here because of this chemical action under a given solution, there will not be any burn or there will not be any heat affected zone or residual stresses formation. Okay, right. Because tooling is made by photographic techniques, patterns can be reproduced easily. So here we are using the photographic techniques. So that's why here pattern making can be easily produced. Okay, so with this let me conclude. So these are the references for this topic. So just let me reiterate certain points. Okay, right here already we have discussed this photochemical milling. Okay, now let us focus on these applications once again. Now various materials, the well-known materials. Okay, aluminum, copper, zinc, steel, lead, nickel, titanium. Okay, so molybdenum, zirconium. Okay, these are the some special materials, even titanium alloy also. Okay, so usually for titanium Ti6Al4V, this alloy will be using in most of the industrial applications and aesthetic applications. Okay, so all these materials will support for the photochemical machining. Okay, even glass, ceramics, and some even plastics also. Okay, so plastics can easily fuse, so that usually if we apply flame, okay, the heat affected zone will be forming, but with chemical action only the surgical material removal will be possible. So here the accuracy is important. Okay, subsequently the quality of the parts and the cost effectiveness are the two important parameters. So almost all the important materials are supporting for this photochemical machining. Okay, right. And these are the various decorative and artistic designs. Okay, see here, here the thickness is very less, 0.013 to 1.3 mm, 1.5 mm. Okay, so it is almost like a delicate sheet. Okay, if we try to make some hole with some drilling machine or something, what will happen, the hole will be forming, along with that some dents will be also forming around that hole. Okay, so here the fine finish, some filters like some materials are making with this chemical photochemical machining. Okay, right, all these are artistic things, designs. See, already we have discussed that 0.013 to 1.5 millimeters. Okay, in generally in various industries such as electronic, okay, automotive, aerospace, telecommunication, computer, and medical, okay, and other industries we are using this photochemical machine. Okay, see here different parts like lead frames, contacts, connectors, probes, and other flat springs that we are making with this photochemical machining process. So these are the various patterns that we can make very easily on thin sheets. Okay, right, these are the advantages. Okay, okay, so with this let me conclude. Okay, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.